This video will show how to create the following two small F# programs. First, creating a new F# file in an empty directory, implementing it with a trivial program, printing the classical phrase "Hello World" to the screen. Then the Hello World program will be replaced with another program, which receives input argument from the command line and also receives keyboard input from the user. This video is part of at least one playlist showing how to do the above with different programming languages. There should be a link to that playlist in the description below. Prerequisites. You, the viewer of this video, are assumed to have some skills in at least some programming language. I will not explain basic concepts such as what is a variable or what is an array or what is a for loop. Even if you have never written source code with F#, you are assumed to be able to understand, for example, what this F# code below does. In this video, I am using Windows 10 and the developer command prompt for VS 2022, which was installed together with my installation of Visual Studio 2022, and then F# was also installed. I start by showing which version of .NET I am using. The .NET version is 6.0. When I start interactive F# with .NET FSI, you can also see that the version of F# is 6.0. By the way, interactive F# is a so-called REPL, Read, Evaluate, Print loop, which can be used for writing and executing F# code directly from the REPL prompt, instead of first writing the source code in a file and then executing it. Now I am navigating to an empty directory, f:\dev. The Windows command dir shows that the directory is empty. In other words, I am starting from an empty directory. Now I create a new directory named F# with the Windows command md. Then I start Visual Studio Code by typing code and a dot, which is the path to the current directory. When Visual Studio Code has started, I create a new script file called arguments_input.fsx in the new directory. The file extension .fsx is used for F# script files, but if you write F# source code in a file to be compiled, you are instead using the file extension .fs. I am now implementing the initial trivial Hello World script by calling the printfn function to print Hello World on the screen. Then I switch to the command window and navigate to the F# directory with the Windows command cd. Now I am showing, with the Windows command dir, that the F# file arguments_inputs.fsx has been created in the directory F#. Then I execute the F# script by typing .NET FSI and then the name of the script file. When the script is executed, the text Hello World is displayed on the screen, just as expected. Now I will replace the initial Hello World implementation with a program that will receive and print arguments from the command line. The program will also ask the user to enter a name and will then print to the screen what the user typed. For this purpose, I have prepared some pseudocode that I will paste into the program, but within comments, since of course it would not be possible to execute. Then I will modify the code by changing it to F# code that can be executed. Now I am showing how the program arguments will be provided for the program when it is executed. The arguments will be added after .NET FSI and the name of the executable file, and then a space between each argument. So here I am showing 3 arguments for the program. Here I am typing open system to be able to use classes that are in the namespace system. For example, the environment and the console classes that I will be using soon. Any program arguments can be accessed from an array returned by the static method environment.getCommandLineArgs which is a method in the class environment with the name getCommandLine_args. I am iterating that array with a for loop, and I choose arg as the name of the iterated element. Inside the loop, the iterated program argument is printed to the screen by calling the function printfn. The string is created with so-called string interpolation, with $sign as prefix before the string, and then %s before the variable name within curly braces. Then I execute the script in a similar way as before, with .NET FSI and then the name of the script file, but now also with 3 program arguments, with a space as a separator between each program argument. When the program is executed with 3 arguments, it does not work quite as expected. The first so-called program argument contains the path to a file fsi.dll, and the second argument contains the name of the script file. Since I wanted to print only the actual program argument, I will change the source code so that the first 2 elements are not printed. Therefore, I disable the for loop by putting it within comments, and will instead implement another for loop, iterating through the index of the array, from 2 to the upper limit defined by the array's property length. Most programming languages, including F#, start the array indexing at 0 for the first element, which means that 2 is the third element. That is, when you start from 2, then you are skipping the first 2 elements with the indices 0 and 1. Since the range operator ... includes the upper limit to the right of the ... I'm using args.length -1 for the upper limit. I also change the string in the loop so that I refer to the array element in args with index I in square brackets. I can also mention that if you would be reading older F# code, then you might come across source code using a dot before the initial square bracket, but that dot is no longer needed, and it is even recommended that you should not use it in new F#6 code, and you can read about it at the URL shown in the inset image. When I then execute the program again, it now works as expected. Now only the actual program arguments are printed to the screen. Note that now the .dll file and the script file are no longer printed as the first 2 elements that are iterated. Now I will show an alternative way to skip the first 2 elements. I am restoring the original loop, which I currently have put within comments, and that loop included 2 elements too much in the beginning that I did not want to include. Now I am first calling the module function array.tail, which returns an array with all elements except the first. Then I call array.tail again, with the returned array as an argument to remove the first element from that array. By calling array.tail twice in that way, you get an array that excludes the first 2 elements from the original array. I will soon show an alternative way to call array.tail twice, but first I will show that this works. When the script is now executed, you can see that it works as it should. Only the actual program arguments are printed on the screen. Now I change the calls to the module function array.tail by now instead using a so-called forward pipe operator, a pipe character and a greater than character, which sends the result from the left side as an argument to what is on the right side, array.tail, and then it is repeated once more, so that the result is sent to another call to the module function array.tail. When I execute the script again, you can see that it works in the same way as before, when I used the other way to call array.tail. Now I will implement the second part of the program, that is, to receive input from the keyboard while the program is being executed. I am using the method stdin.readline to read input from the keyboard and receives the returned string into a variable name. By the way, stdin is a so-called operator that returns the text reader in the console.in property, and the stdout that I also will use soon is an operator that returns the text writer in the console.out property. And console is a class in the namespace system. The question, "What is your name?" is printed to the screen by using the method stdout.write. I am using write instead of writeline to not include a line break at the end of the line, because I want the input prompt shown by the call stdin.readline to be displayed on the same line. The content of the variable name is printed with stdout.writeline. Here I am using writeline instead of write to include a line break at the end of the line. The string that begins with hello is created as a so-called interpolated string with $sign as prefix and then the variable name within curly braces. When I then execute, it works exactly as expected. To print text to the screen, I have used the function printfn and the methods stdout.write and writeline. And to read input from the keyboard, I have used stdin.readline. Now I will show that an alternative is to use methods from the class console, the methods writeline and write and readline. When I then execute again, you can see that it works in the same way as before. So far, I have executed the F# code as a script file with .NET FSI and then the file name. But now I will show how to create and execute a .NET project. I first navigate up one directory with the command cd ... Then I generate a new console project, which is a command line program without a visual interface. I am doing this with the command .NET new console with the flag -lang F# to specify that I want to create an F# project instead of creating a C# or Visual Basic project. I am also using the flag -o to specify the name of the subdirectory to be created for the project. I am using the name F#2 only because the previously used name F# is already existing as a subdirectory name. In addition, I could use the flag --framework to specify an explicit framework version, but I will instead generate a project with the default version, which here will be .NET 6, which I will soon show in the project file with the file extension .fsproy. The command I now was running generated a new project in the F#2 directory. Now I am navigating into the created directory F#2 by using the command cd F#2. From there, I execute the project with the command .NET run. The generated project is now printing hello world from F# on the screen when executed. Now I will replace the generated hello world program with the program I created earlier in this video in the F# directory. Therefore, I am switching to Visual Studio Code, which now shows both subdirectories, F# and F#2. First, I will show the project file with the file extension .fsproy in the generated project F#2. As you can see, target framework is 6.0, which became the default when I omitted the flag --framework when I recently ran the command .NET new console to generate the project. The generated hello world code in the F#2 directory is located in the file program.fs, and I will now replace that source code with the source code I have previously written in the file arguments_inputs.fsx in the directory F#. Therefore, I copy that source code and paste it into the file program.fs. To execute the program, I can now use the command .NET run, and then program arguments can be added with a space between each argument. But it does not work quite as expected. The first argument, ABC, seems to be skipped. The problem is that the so-called program arguments that are automatically provided at the beginning, before the actual program arguments, do not become quite the same when executing as a script with .NET FSI and then the file name, as when you are executing a project with .NET Run. I will now show that difference more clearly by first commenting out both calls to the module function array.tail, which created a new list without the first two elements of the arguments array. When I then execute again, you can see that there is now one first element, which is the project's compiled DLL file, F#2DLL, which can be compared to the two first arguments of the previous script execution with .NET FSI. And then the first element was a DLL file, fsi.dll, and then the second argument was the name of the script file. To avoid the first element with the DLL file F#2DLL, I can therefore call the module function array.tail once instead of calling it twice, which I did earlier when the program executed as a script with .NET FSI. When I execute again, you can see that it works as expected. Now only the actual program arguments are printed to the screen. So far, I have executed the program with a so-called implicit entry point, which means that the code in the file is executed from beginning to end, without it being located in any special function that acts as a so-called entry point. Now I will change the program a bit by putting the code in a main function, which is a so-called explicit entry point. Such a main function can receive program arguments as an argument to the function main. Therefore, you do not need to call the method environment.getCommandLineArgs, which I have previously used to receive the arguments to a variable args, so I disable it by putting it behind comments. Since I chose the same name, args, for the main function's argument, I do not need to change the for loop where args is used. You must also use the attribute entry point above the function main within square brackets and less than and greater than characters. The main function should also return an integer, an int, so therefore I return a 0, which is the return code that is usually used when no error occurred. When I execute again, you can see that it works as before.